In today's session, we are going to discuss now about the heap. Okay, so when I say this is heap, so heap means this is something binary tree. Again, this is a binary tree. So we have studied the binary search tree. So in what is the speciality of binary search tree? In binary search tree, there is means left is smaller than the root and right is the bigger than root. That is the property of uh, um, a binary search tree. Okay, no matter whether tree is balanced or not, or no matter where how many elements are more. So that is binary tree. In avian tree, balancing was there. But when we talk about the heap tree, so heap tree is something which follows the property of A, A, C, B and T. This is almost means it says this is almost complete binary tree. Almost complete binary tree in the sense ACBT almost complete binary tree means let's suppose we have to insert the elements like 2, 9, 5, 7. Then let's say 11 is there. We have to insert 17, then 14, then 25. Is left and right should be completed. Okay, I means you have to you have to insert the element. Two three things you have to follow over here. The elements that will be inserted will be in form of number one. First of all, there will be a left insertion. First of all, there will be a left insertion. Then at the second, there will be right side insertion. Okay. So when both left and side insertion are completed, at third, it will go to next level. Okay, so level by level it works. So it works on level by level. So if a level is not completed, we can it cannot create a new child. Okay, so the insertion will be done level by level. Okay, so by this it will be containing the property of almost complete binary tree. So the heap is also a kind of binary tree. Heap, uh, we say heap is a kind of binary tree. We say it is a binary tree. So in binary tree, there are two childs are there. Now, unlike left and right insertion, you have to keep in mind. And once left and right are completed, you can move to next level. That's it. Okay.
Okay.
Let's see how uh, how you can do these insertion. So let's suppose you have I'm taking this and I'm taking this. Okay, so now one by one will insert. So how will insert? First of all, two will come. Okay, now at the left of two, next element will come at left of it. Okay, क्या हो रहा है आज? Why it is not moving properly? Why it is hanging so much? So let's see if I'll take this. So first of all, two will come. Okay. At left of two, nine will come, right? So first of all, it will fill the left, then it will fill the right. So next value five will come. Okay. Now left and right both are completed. Now there is no space of new node. So now it will go to the next level. So now next element will come here, right? This will be seven. Okay, then this will be 11. Okay,
Okay.
Then next now left and right are completed. Now left of this will be completed, so it will come as 17. Now next will be coming as 14. Okay, so it will ensure now you can see whatever elements are there. Every element has left and right both. Okay, and then now 25. 25 is here, so 25. Now no elements are available after 25. So our process is getting completed at 25. Okay, so like this you can say this is a complete binary tree now. Okay, understood.
Yeah.
So this is how this heap is there. And now the next process, the one and the two processes come over here is means how this can be managed. One, you can do it with maxify heap. Maxify heap. So what is in maxify heap? In maxify heap, what we do is we ensure that root is always greater than its children. Okay. And second thing is minify heap. So minify heap is always where root is smaller than a children. Okay. So in maxify heap, root is bigger than child, and the minify heap root is smaller than child, right? So no, you can do it while insertion also, or after the insertion you can apply the heapify process.
Okay.
In Maxify, what you have to do, first of all, you have to check each element from the root. So at the root, you can see right now there is this is 2 is smaller. Okay, here I'll take this, and here I'll take this brush. Okay, so you can see here this 2 is smaller and 9 is bigger. Okay. And so what you will do, this 9 will come here and this 2 will come here, right? So now structure will be in the next stage, the structure will be like 9. Why it is not working, moving properly? It is creating disturbance. Earlier it was moving very much smooth. So let's say here we have this will be 9. Okay, and 2 will come here. Okay, now this 2 will be compared uh, with this further stages. So 7 and 11 will be compared. It will then 25. So like this, this process will be compared where every element will go to the root to ensure that the root is bigger than um, the its children. So at last, what will happen? The biggest element will be at top position, and the smallest element will be at the lower side of swap with this. So 11 will come here, and then 2 will come here. Okay, and then later on this will be going to this place, and this will go to this place. Again 25 will come to this place, and 25 and this will come to this place. So like that, this swapping will ensure that root is bigger than the child. In the same way, in the minify, it will be ensured that this root is smaller than child. So in that case, 2 will be at top, and then 5, and then 7 will come up. Understood? The heap,
Yeah.
heap and what is heapify process, what is minify heap, and what is maxify heap process.
Yes.
All thing correct? Understood?
Yeah.
Understood?
Heapify
Okay.
ensures the heap property is maintained.
Yes, it is means whatever property you select means if you want to make it maxify heap or if you want to maintain it, the minify heap. And the one thing you have to ensure is it is ACVT, means ACVT almost complete binary tree must be ensured, right? You cannot say a complete binary tree because the number of elements are not in your control. So like in this case, this 25 is there, right? So it could be complete binary tree when there is one element at here itself, but there is no given. But it needs to be ensured if this element is there before that, all should be filled on this level, right?
Okay.
The previous
Yeah.
level should be filled first, then only next level should start. That's how it becomes the almost complete binary tree. So the insertion will be first left, then right, then first left, then right, then first left, then right. Like that, there will be insertion. Unlike binary tree or a wheel tree, which compares first and then do the insertion and then do the rotation. Okay.
Okay.
So this is the main thing that is involved with this almost complete binary tree. Okay. So now difficult. So let me do the implementation for this. Okay, now in this, I'll make a new program. And a heap sort will also will be working in the similar manner. So I'll just show you what heap how heap sort works. First, let us do this small implementation for this. Then we'll understand what is heap sort. This is heap sort is very simple once you understand this.
Okay.
Give me a second. I'm just give me a second. I'm getting a call. First of all, 10 will come here. Okay. Once 10 will come here, next element will be 5. So 5 will come here. Okay. And 9 will come at this right. Okay. Then what will happen? 7 will come at left over here. 4 will come at right. Then after that, 9 will come.
Okay.
So 9, not 9. this 3 will come. So you can see here now when heap is created, all roots are always bigger than their uh, um, um, bigger than their elements. Okay. So this is the maxify heap. In the same way, now you if you want means you can understand this process how this is getting calculated. So first of all, it is getting created in left and means once element is coming one by one, it is trying to do this. So if self is the element where you are standing out, okay, then the left is the element at the left side, then self dot array of left and self dot array of largest. So whatever the largest element is there, that will be always there at the at the largest. So I is the first element that has been supplied. So for this case, if you see, first of all, 5 will come into this heap. Okay, once 5 will come at that point, you can see here. First of all, build heap will come, and this heap will take one element at a time. So I in range. So first of all, self of n has come. Okay. um and now what will happen, this I is inserted. So first of all, 5 has come. Okay, 5, when 5 has come, then there is no problem. When the second element comes as 10, now when the second element will come over here, so here now the largest element is at 10, okay, and now when this
Sir, your voice is breaking.